Many of us have been seeing this world where, of course, we grew up in the days of classical science, enjoyed the birth of computational science, and everywhere around us seeing the emergence of data-driven discovery. And of course, our first CS PhD, Jim Gray, was certainly one of the groundbreakers in this whole area. If you came to BIDS 2 years ago about big data, or last year with AmpLab, it's been the theme we've been exploring, of course, and we have a critical role in enabling this much broader community. Part of what you're going to see is that carrying forward. That essentially, for every field of science now, the data-driven discovery is right at the core of it for all X across campus. And this is just a brief touch, reaching all the way, of course, from the physical and life sciences to the social sciences, sociology, commerce, governance, everything else. And certainly from even what you've seen today, this incredible growth in so many different modes, different abilities, if you will. It's like we're discovering new telescopes, new microscopes all around us. Copious amounts of information that's noisy, complicated, and we have to go find those beautiful needles down inside of that haystack. This is happening everywhere at Berkeley and has been happening everywhere at Berkeley. This is just a touch of some of the places. AmpLab, of course, you've heard about. Our colleagues in statistics tying in with neuroscience, in seismology, Fernando Perez at the heart of IPython, Adam Arkin in K-Base, more bugs inside your brain, around your brain, the economy everywhere. So last year, and I touched on this earlier in my opening remarks, we were so excited about this incredible pace of one after another, these nationwide efforts that came together at Berkeley, such as the Simons Foundation, $60 million over 10 years. And what happened over last year was more Sloan Foundation together putting out another one of these challenges to go really think, how would you transform the academic institution around data science? How would you create new opportunities to really increase the pace, increase the capacity, increase the ability of all of these fields to dig in and do this? It too went through many, many rounds of process. What was so exciting was how all the campus came together. We announced a Saturday 8 a.m. workshop on Thursday evening and had 120 people from all walks of campus coming together. This was Saul and I trying to moderate it, and we were putting ideas on the scale from low-hanging fruit to top of the trees on one dimension, and from the sublime to the ridiculous on the other, to just try to understand this incredibly complicated landscape. We won, but more on that. The other piece was, how would you support activity like this? And what you see here on this map, the buildings in gold of places where significant data science was happening everywhere throughout campus. And where should such an institute be? Well, for the same reason that 100 years ago you built the library right in the center of campus, it really needed to be there, and it is. You can see there the future home, soon-to-be future home of the Berkeley Institute of Data Science will be right there at the front of the Doe Memorial Library, bringing very many disciplines, methodologists, computer science, statistics, mathematics, with life science, biology, social science, and so forth. So that's what we'll have to talk to you about next year. The leadership also spans that entire spectrum. You can see a sense of the in blue, the technical fields, and in gold, the social science and so forth. So we're really reaching out beyond the traditional disciplines. So that's a little bit of what we've enjoyed in getting to here over the last year. And I'd like to introduce to you Saul Perlmutter, who is the director of BIDS. He also, of course, heads the supernova cosmology project up at the lab. And some of you will remember him as Nobel Prize winner in Physics 2011 for helping us understand the expanding universe. He's certainly expanding our universe. Saul, can I hand this over to you?
So picking up the story, I think that what was unusual about this particular congregation of members of the Berkeley community was the fact that everybody was coming at it from completely different angles with completely different motivations. I'll just give you my story just very quickly as an example, where we were asking questions about the history of the expansion of the universe, about what is the universe made out of that we live in. Right now we're in the midst of trying to figure out what most of the universe consists of. This dark energy that's apparently accelerating the universe, and this kind of project goes back to. Basically brings many of us at a fairly early stage into this data science area. So my own work, for example, and I think many people had the same experience, began with what seemed like a fairly simple need, but turns very quickly, even back in the early 1980s, into what was at that time a large amount of data. And the problems that we were facing is we want to look through the sky automatically and find changing objects, supernova, and then be able to respond to them robotically so that the telescope would go back and immediately follow up interesting objects without a human having to intervene, so you didn't miss the opportunity in the middle of the night. The problem boils down to one of these needle in the haystack jobs, where you need to be able to find a very rare event amidst many, many things. And of course, that should sound familiar to anybody nowadays who's doing data science. And the techniques, of course, as you've increased the scale of the problem and go from the few hundreds of megabytes a night, which seemed really big back then, to the we're working now towards 50 terabytes per night processed. You're using all the various techniques that are being developed along the way. So boosted decision trees, came into our vocabulary, although we were all astrophysicists. And you are finding the same thing in many fields, where you have to compare it against large simulations for the theory. So in this case, supercomputer simulations of the supernova, and then also large simulations of the actual experiment in order to do the statistics. So there are these often these big Monte Carlo jobs that need to be done, and obviously the Markov chain Monte Carlo techniques have become a very standard way of approaching those. It's not just in my own group's work, but down the hall, where we're looking at the glow left over from the Big Bang, the cosmic microwave background. My colleagues there, of course, had dramatically larger data sets to work with large correlations across, correlation matrices across all the pixels of the sky that they're looking at. That had to be dealt with. So they are facing very similar problems. You go further afield, and of course you find, in this case, walking around just the Lawrence Berkeley Laboratory, you start finding that these same kinds of problems and variations on them start showing up in other fields, of course. And then when the whole university showed up at that Saturday morning session that David was talking about, we've found that people have so much in common that we're worrying about, and yet we're not having much of a chance to talk to each other. And there's the whole methodological expertise available in the CS side of the house, the statistics side of the house, and the information science school. And nobody is having a easy access to each other's problems or answers. And obviously, there was a real excitement in the room about the possibility of doing something about that. Now, with all these problems, generally it's not the amount of computing that you need that's the barrier. So the real question is, what is missing? Why is it that we're not just flourishing in our sciences, taking advantage of all the great capabilities that we should be able to use in data sciences? So let me walk through a few of the issues that we identified when we started talking about this problem. First, we were commenting that in the standard academic model of research, it's very difficult to make the software that we're building at all progressive. The grad students and the postdocs and the scientists come and go, and they don't leave behind much that more than that maybe the next person might be able to use. Within another generation or so, everything's lost. And I've now watched many top-notch collaborations do great software and data analysis, data science, and then everybody trying to reinvent it, perhaps a little bit better, perhaps a little bit worse, the next generation. No sense that things are building on top of each other. And so we really would like to find ways to make it easier for people to find what each other's doing, and then also to be able to contribute and maintain the various different solutions to these problems over the years. I see it as potentially as big a difference as trying to do science without the peer-reviewed journal, and perhaps the possibility of trying to do science where you get to build on top of what other people have done before you. We saw sociological problems, that in the academic world, there's a problem for the career paths, that it's not obvious that somebody who falls between the CS world and the science world, because they are experts in both, but they've concentrated on being able to integrate them together, those are very difficult to find homes for in the standard departments in a university. So that's it seems like a somewhat trivial problem, but of course, as you know, institutional problems are always very challenging. Now, there's also the problem that we have not really thought of data science training for all of our undergraduates, graduates, students, postdocs, as just a bread and butter thing, like learning to write an essay. Everybody knows how to write an essay. It's a standard tool. We do not have quite that same fluency across the whole university that you could use when an undergraduate wants to come work in a research group. And obviously, that's something that we could do better in. There are perhaps less obvious problems that I thought we were starting to look at. One is that there's a sense that the programming environments that we work in as scientists are really not optimally, mentally ergonomically efficient for getting the jobs done. They tend to distract us from what the science goal is that we're after. You spend an awful lot of time trying to solve problems that, in some sense, aren't really what you should be what you're trained to do, and there should be ways to make that more effective. We think that, as I mentioned, that there really should be a better chance to bridge the gaps between what turn out to be the interests and needs of the domain scientists and then the interests and needs of the methodologists. So very often you'll find that you have an interesting problem, you start talking to a colleague in computer science or statistics, and you realize that they actually have solved that problem, or they can solve that problem in the abstract, but there isn't anybody who's really has the capability to bridge all the gaps between what you're doing and what they're doing, so that there's real code on the table that you can actually run. And we think that's a real opportunity. And then we're thinking that these problems that we've identified are the ones that we've come up with just through introspection. And I think we have very strong beliefs, many of us, that we know what's wrong in many of these situations. But we can look into this. This is something that you can actually study. You can do ethnography and find out more about. So that seems to be a part of one of the ingredients. So if we put this together, we thought there's some great potential gains to be had. I think that we could help the parts of the academic environment, academic world, who are not as data savvy as the people in this room. And so you should be able to make great gains in the areas where they could be using data science and they aren't already. There's the possible fun opportunity for using this as an intellectual bridge across the university to allow people who are traditionally in different silos working in their own fields to have the fun of working in each other's fields. Since now, in many cases, the solution that you've invented for cosmology, for example, could actually be something useful for neurosciences or vice versa. And perhaps even between methodology fields and the science fields themselves. So I felt that there was a lot of fertile opportunity here, and I think everybody had that sense coming out of these discussions. We had organized this particular effort with the Moore and Sloan Foundation around the idea of having some working groups that would be addressing things like the career paths, education and training, software tools, open science, reproducibility, the working space and culture that brings people together, and this ethnography that I was describing. And the idea would be that would really be a place to bring together not only the various different scientific domains, but the various different methodological domains into these projects that might address those problems that I just described. So I will leave up the BID's goals, but I thought that it might be interesting actually to turn the story back to this group and to a little bit of conversation between David and myself as well, and to give a little more feeling for the texture what we're after, and hear what your thoughts are also. So,
We'll tee this up. I get to ask a question or two, and we'll sort of shift into a conversation. And we do have a mic there. If already in your heads questions are forming, or we'll spend a minute or two. So I guess to kick this off, in this year or so we've been at it, of course we all see Saul, as the brilliant astrophysicist, and yet you've been really excited about the ethnographic aspects. And I can imagine maybe we're looking at a kind of intellectual inversion where young people coming through have talents that their experienced advisors, are new to. This whole question of can we really accelerate the pace of innovation? I wonder if you could expand a little bit on, do you see that ethnography is going to be a tool and how that might be?
Yeah, so I began mentioning this idea about trying to use ethnography in this area. And it seemed to me, looking at what was going on and talking to many others, that there's so many different ways in which people are getting held up from working with their data and being able to get results. And that we may or may not have identified the right ones as being the low-hanging fruit that we could actually improve. It's possible. I was imagining that you could do something as simple as what a soap company does when they want to understand, what turns out to be the hard part about cleaning your house, and then they go and they study what people actually are stuck on and what things slow them down. Similarly, if you did things like the random time probes of what is holding you up today at this instant, 2:30 on a Wednesday afternoon, and randomly checked in with people who are trying to get their science done, you might discover that they're actually having hard times with things that you never thought they really should be wasting their time on, that they would have a hard time with. Or you might discover that the things that we imagined would be the hard part were the hard part, and then you'd feel very confident that that's the place to focus our attention. So I think it's an opportunity also to explore the question of, are the problems different for a young undergraduate trying to come into the field, for a scientist who's deeply engaged with data science, well-trained, and yet still finds barriers to it, or the problems of a professor, let's say, who used to be a hotshot on the computer, but now is trying to run a research group and realizes that they're little by little losing touch with their ability to access the data in ways that used to be very automatic, when you used to plot things on your, on the graphs by hand. So I thought that there may be some interesting results that we find in that could help us shape the job for the future.
Let me pick up on that a little bit. Certainly, the tone in the industry, agile development, and so forth, that the more rapidly you can get an initial solution, the more rapidly you can innovate. So if next year we're sitting there in Doe Library and the BID Center and we've accelerated the pace of innovation in science, what's it like there? What do you think that will be?
I mean, the interesting thing is that today I have this strong sense that a large fraction of the research community doing science research of any sort is bogged down for often a year or so trying to get a paper out because of the slowness of the data science work. And what would be really exciting, first of all, would be to have that sense of the fast iteration and excitement that we all love to feel when we're doing science, that we get the result, we understand it, and we move on to the next iteration of that result. So within a field, I think that could be very exciting. But the other point you're making is that if we really get this right in terms of a sociology, this could be one of these moments where you actually are seeing people back and forth across the whole university talking to each other and trading ideas in fields that they ordinarily would never have any access to or a chance to help with. And I think that would, by itself, just be it could transform what it feels like to be in a university.
Interesting. Those intellectual bridges. Well, maybe as a transition, and I think we can take one or two of your questions. So in some places, we might imagine that in various parts of big data, the industrial world is actually out ahead. And often when we make the list, these tremendous commonalities and whatnot. Where do you think some of the parallels might be, or where things that come out of this will, enable new breakthroughs on the commercial side?
Yeah, no, I was thinking about the fact that we very rarely in the academic world have time to be able to go and look and see what's going on in the commercial world that would benefit us. And I'm assuming that in many fields of this data science area, there are techniques and approaches that would make a huge difference for us if we were able to get access to them and work with them. But conversely, I was also thinking that, first of all, you put a bunch of scientists to work trying to solve their own problems, and they often discover ways of solving problems that nobody ever thought of before, and that might be very helpful in the commercial world as well. And finally, I had this sense that today, in the commercial world, when I've spoken to them and asked them how they solve a problem that we're facing in one of our astrophysics projects, often I discover that in some sense they're brute force papering the problem with programmers, that you actually can hire enough people that you can solve a problem that, with maybe 100 people that we are trying to solve with 2 people. And I realize, okay, that's why it looks so good, in the commercial world. But if we can make it more and more efficient, if we can make it possible for those 2 people to get closer to what you are able to do with the 100 people in the commercial world, I'm hoping at some point that payback will help the commercial world as well, because obviously they'd rather not hire the 100 people, given the option.
Factor of 50. At this point, I'd love to invite 1 or 2 questions. There's a mic there, and that'll give us a little arbitration and avoid us having to repeat it.
Thank you very much. I'm Nikhil Krishnan from C3 Energy, and as a big data analytics company in the commercial world, this is tremendously exciting to hear about what you're describing. I had kind of 2 thoughts, and maybe they're both pretty selfish, but I would like to hear your thoughts on both of them. The first is really thinking about our need as a commercial company. We're working on some of the most exciting big data problems. One of the things we're tremendously excited about with an institute like this is how do we actually collaborate? Maybe you could talk a bit about how you're thinking about that. And then a second piece is talent. One of the things we constantly struggle with is it's just tremendously hard to get the right talent to solve big data problems. And these are, I'm not talking about just programming skills, but just the tremendous insight and the cross-disciplinary effort required here. So we'd love to hear your thoughts on both.
So let me take a cut at it, and I think I'm going to pass it back to David right afterwards, because I was going to say that we very much have been interested in this idea of having this be a very open institution with the possibility of experts in the commercial world as well as in the sciences having a chance to work together on some of these problems. For exactly the reasons I just said, it feels like there's a lot that we could be learning back and forth from it. So we've been very much discussing the possibility of setting up consortia of industry that might be part of this, but more personally, actually having space in that institutional space in the Doe Library where people could come and spend time. And the idea being that you might have somebody from industry coming and doing a small mini sabbatical with us, or even visiting half day a week if they had the time to do it. We might have people from our organization going out and doing internships in industry as well. And so we thought that actually might be a very fertile direction. But David's been thinking about this also very practically as well.
That's true, and let me thank you for the question. Great tee-up. In an industrial consortium, it may be selfish, but we have the same selfish interest, so we're very interested in building these collaborations. It's an interesting thing to build the right collaborative structure for something like this. So what's obvious is we can put together our industrial program with many players, maintain that engagement. It's also pretty clear how you could get sponsorship and whatnot around particular activities, and this is more typically what we do. So we've been doing a bit of a listening tour, talking with various large players, small players, to understand what should the relationship be like for something that's as broad and sweeping as this. Now, it's clear one of the places that we're entirely fellow travelers is this notion of educating a whole new knowledge workforce. And we have that in every part of the university. Every industry that I know of is going through that same transformation. And there's a whole side of this institute that's focused on that educational program. So we're all ears, and the wonderful thing with the Moore Sloan seed money, if you will, is it gives us a chance to really think about what would be the right structure rather than just putting this together very rapidly. So we're very interested to listen and to build that relationship. Please.
Yeah, so it's very exciting to know the new Institute for Big Data and Data Science. So to support big data, we need huge computing power, which further use a huge amount of electric power, right? So as a building block for big data, the data centers all over the world consume as much as electricity as United Kingdom does, and it's increasing very fast, more than 10% per year. So my own PhD thesis is about how to use renewable energy to power data centers, and furthermore, to use data center to improve the overall sustainability of our power system, for example, through demand response. So I'm not sure whether this kind of research also going on within the Institute of Data Science. Yeah, thank you.
I think it's very interesting. We've not focused yet on that, but I should say that we are very much at this point in a listening mode to the whole community, and we're trying to pull in as many ideas as we can for things that we could do that would make sense to do in this integrative way, and that would help most. So any project, and this might be an example that we think would tie together different expertise. And has to do with this problem of how do we advance the sciences and the academic world in terms of understanding it may be fair game. So we don't yet have something specifically on that topic, but we obviously have connections with many of the supercomputer experts as well.
And it's a great example of why this is such a wonderful place to be. That happens to be an area that my group has looked at quite a bit. We're very focused on the 3% of the world's energy that goes into computing and the other 90% and how we can use the 3%. We've even done all of these studies of taking the big NERSC supercomputer centers and what if we were running them after wind and how is it? And beautiful results like an energy-aware scheduler will save you as much as 5 cluster hours, which for a 10 megawatt machine is about a football field. So of course, but it's just one of the many, many examples of where the science, the engineering, the data all start to come together. Perhaps with that, we can turn this back to Manish and Saul and all of you. Let me thank you all for joining us before we head back to our break.